Welcome back. In this demonstration video, I'd like to show you in detail the main features of the bend saw I finished a few days back. I'll also try to explain how to adjust it to achieve perfect cuts. It's made entirely of birch plywood, so after cutting all the parts to size, the only thing we have to do is to assemble it after machining the parts and making some rebates. We could use cheaper, lighter plywood or even MDF. The plans also include this support with wheels and a handle. I've come up with this system to make the saw more stable while I'm using it and so that I can move it around the shop. I've equipped it with a 1 horsepower 1500 RPM motor and lowered the revolutions to 1000 with pulleys. To activate the motor and turn on the saw, I've installed an emergency switch. Since these wheels are 355 millimeters in diameter, I can get a cutting speed of a little over 1000 meters per minute, more than enough for this saw. I've cut a slot in the cover that will make it possible to lift the top wheel a little higher up. This is because I've bought some blades measured in inches, which are slightly longer than the metric counterparts. When we open the bottom door, we can see the dust collection system. It's quite efficient due to its location, and after using the saw, there's barely any sawdust left. I've also attached an exercise band to the wheels, reducing the amount of noise when operating the saw. Finally, I've added this part which serves two purposes: reinforcing the work table and covering the blade on the lower part of the table for safety reasons. The table I've designed is larger than usual because I like having extra room when working. However, due to that, when applying pressure on it, it moved a little on the right. In order to tilt the table, we must also remove the zero clearance. Turn the adjust knob and choose an angle. Because I placed this knob here, I can tilt it to 45 degrees, but I only have to cut a small recess on the underside of the table in order to solve that. On the other side, I put in this screw to adjust the table so that it's always perpendicular to the blade. By raising the guidepost all the way up, I can get a maximum cut height of 230 millimeters, which can easily be increased by lengthening the parts that make up the frame of the saw. Before raising and lowering the post, the saw must be shut down to avoid potential accidents when touching the blade. Now's a good time to explain how to set the blade tension according to our needs. We could use a tension meter, but they tend to be pricey. There's another effective method known as flutter. We set the guidepost all the way up, we tension the blade slightly and turn on the motor. While the blade is running, we loosen it little by little until it starts to flutter. When that happens, we gradually tension the blade again until it stops fluttering. This means we've found the right amount of tension. This method applies to all sorts of blades. We should of course do all of this with doors closed for safety. I'm going to test the one that's installed. It's 3 millimeters wide, making it suitable for tight curves. I set the top guides to about 10 millimeters above the workpiece. The blade cuts smoothly, and we can see how well it can handle curves, even on a workpiece as thick as this one. Now I'll show you how to change and calibrate the blade. I bring the guidepost almost all the way down, detension the blade, and remove the front piece and the zero clearance. Now I can remove the blade carefully. These are the 3 types of blades I use most often. This is the one I've just removed, which as I've said is 3 millimeters wide, 0.6 millimeters thick, with 14 teeth per inch. It's perfect for tight corners. This one is medium-sized. It's 10 millimeters wide, 0.5 millimeters thick, with 5 teeth per inch. It's ideal for straight cuts on wood up to 120 millimeters thick and curves that are not too tight. And this is the biggest size I use on a normal basis. It's 20 millimeters wide, 0.4 millimeters thick, and has 4 teeth per inch. It's suitable for cutting wood over 120 millimeters thick, such as big logs. Incidentally, a few days ago I received this blade that was not properly aligned when welded. I'll put it next to this piece of wood so that you can see what I mean. I can still use it, but I'll have to take some precautions. I'm going to install it in the saw. First, I move the guides and bearings towards the back. I also loosen and separate the Teflon guides. I put the blade in the saw. I have to lower the top wheel a little. I tighten the blade and make sure it's in the center of the wheels. Looks like I'll have to tilt the top wheel a little. This should do. I'm going to demonstrate the problem I was just talking about. You can easily see how the blade has been improperly welded, so it's going to make more noise than it should when it rubs against the bearings. While I'm at it, I can also check how much the saw's frame bends when tensioning the blade with a probe indicator. I put it under the guidepost and set it to 0 while the blade is completely slack. Now I start tensioning the blade, and once it's reached the appropriate tension, we can see the frame has bent 0.2 millimeters, an acceptable result considering this is the biggest blade I'll be using. It seems plywood performs adequately in this kind of medium-sized bandsaw. Now I'll show you how to adjust the blade's guideposts. I set the post to medium height. First, I adjust the depth of the Teflon guides in relation to the blade until they're just behind its teeth. Then I set the depth of the bearing until it touches the blade. Using a piece of paper, I adjust the separation between the blade and the Teflon guides like this. We must follow the same steps with the bottom guides. Once the blade has been calibrated, I'll try to cut this birch log I had in my workshop. Birch wood is of medium hardness, but if it's very dry, as is the case with this one, it becomes a lot harder. First, I set the height of the top guidepost and start cutting carefully. Although the blade is improperly welded, it seems to be doing its job well, and I can cut the birch quite easily. I turned the piece of birch on its side and set the guidepost height again. This time the height of the cut is 200 millimeters. Little by little I make the cut. It advances smoothly without forcing the bandsaw too much. I attach the fence to cut 2 equal parts. Again, I do it slowly, and I finish cutting it without a hitch. Getting straight cuts with big depth depends on 3 factors: having a sharp blade, choosing the right tension, and cutting slowly without forcing the saw. I've also made this slat for the bandsaw, which I'm going to use to cut both birch pieces. This sled can also be used to make circular cuts, as shown in a previous video. A few days ago, I made this miter gauge that will come in handy when cutting wood parts at any angle we desire. The collection system works perfectly. Even after making all those cuts, there's barely any sawdust inside the saw. Finally, I'd like to show you how to fold your bent saw blades for easier storage or transport. With the blade's teeth facing forward, we step on the middle and move our hands to the sides, with index fingers outstretched. Now we fold the blade by trying to bring our index fingers together. We lift our foot and the blade will coil up, making it more compact. That's all for today. See you next time.